All right, this is Mr. Weyrich. I'm going to be going over this compound probability set of notes and a little bit on the delta math with you today. It starts off saying think about the independent and dependent. The reason you got to think about the independent and dependent that we had yesterday is when you're calculating compound probability, it's important to remember if the probability at any point is going to change or switch or anything like that. So we're going to take a look at this. We're going to kind of put these together. We're going to talk about why it is what it is. The formulas here are kind of weird. For independent events, something that it doesn't matter if they're connected or not, you take the probability of A and you multiply it by the probability of B. For the dependent things, it's probability of A multiplied by the probability of B given A. So again, on this second one, the B given A, we're looking at like a reduced probability, either reduced on the top or reduced on the bottom because of the way that something turned out. So this first one is our example. There are 4 nickels and 6 dimes in your pocket. You randomly pick a coin out of your pocket and then return it to your pocket. Then you randomly pick another coin. What is the probability that both coins are nickels? It's independent in this case. So it's kind of important that you understand that. The probability that the first one is a nickel is 4 out of the 10. Because you put it back, the probability that the second one is a nickel is also 4 out of 10. So we would go to like our Desmos and we would say 4 out of 10, and we're going to multiply that by 4 out of 10. Now this is going to give us a decimal here. It's probably going to need to be a fraction. That's going to end up being 4 out of 25 because it would be 16 out of 100 and it would reduce. Remember that you can click this little button over here if you're in the full version of Desmos and switch between those decimals and fractions. Okay. So the next one, a card is chosen at random from a deck, then put back and shuffled in. What is the probability that the first card drawn is a heart? It says in, I'm going to change that to is a heart, and then the second card is an ace. So you have to know a little bit about decks of cards in this one. The probability that's going to be a heart, there are 4 suits in a deck of cards. So the hearts would be 1 out of every 4 cards. So I'm going to say this is 1 out of 4. Then for the next one on our compound probability, the second card is an ace. There are 4 aces, 1 out of every 13 because there's 1 in each suit. So we're going to multiply 1 in 4 by 1 in every 13. And if we make this into a fraction, it's 1 out of 52. So what this is telling us that if we did this exact same experiment 52 times, the first card being a heart and the second card being an ace, would be, if we did it 52 times, this would only happen once. Okay, so it's kind of rare that would work out. Didn't mean to grab those notes and move them. The next one, you have a bag of 22 marbles, 8 blue, 11 green, 3 red. If you pull 3 marbles out of the bag individually without replacement, what is the probability that the first marble is red, second marble is blue, the third marble is green? So we got to do a little bit of complicated math here. This is the dependent situation. So stuff is going to change every single time. The probability that the first marble is red, there's 8 plus 11 is 19, plus 3 is 22. So there's 3 red out of those 22. So I'm going to put my first one as 3 out of 22. Okay. Then it's saying the next one is going to be blue. Well, we kept that first marble out. So instead of 22, we have 21 now. But there's still 8 blue. So this one is going to be a little bit of an adjusted probability. We're not still going out of 21, so we're multiplying that by 8 out of 21. Okay, we're reducing the number of marbles as we go because we're keeping them in our hand. But we always calculate this like the first thing really did happen. So like all those times that we drew the first one and it was green, we didn't just stop, but we don't calculate it like the first one's green. We calculate it like the first one's red. Okay, second one is blue, that's 8 out of the 21 remaining. Third one's green, that's 11 out of the now 20 remaining. So 11 out of 20. Each time the probability of this shifts from what it would be if we were looking for the first one. And when we put these all together, we end up with a 1 in 35 chance of that happening. Okay, so it's definitely adjustment, and you got to kind of keep track of stuff. Desmos is probably going to be better than trying to do this on like an iPhone calculator, or even maybe one of the blue calculators. Desmos is going to be a little bit better for this because of the complicated fractions involved. Okay, last one, we have a bag of 15 marbles, 3 blue, 7 green, 5 red. If you pull a marble out of the bag, look at it, put it back, and pull out another, what's the probability that both marbles were green? This one is going to be like an independent situation because we're going to look at it, we're going to put it back. So both times this is 7 out of 15. So this one just needs to be 7 out of 15 times 7 out of 15. Ooh, maybe not like that. Times 7 out of 15. Do make sure that they're separate there. That'd be 49 out of 225 when we put it back into fraction form. So it definitely adjusts, it changes when you need two things to happen in the proper order like that. So that's what we're looking at for that set. Oh, did not mean to move that. Goodness gracious. Okay, so that's that. So then when we look at the Delta math and we look at the skills and we look at the questions, let's see this problem. A box contains 7 milk chocolates and 5 dark chocolates. You randomly pick a chocolate and eat it. Then you randomly pick another piece. Both pieces are milk chocolate. What's the probability here? So again, like this is dependent because we're eating it. We're not putting it back. The first one is 7 milk chocolates out of 12 total. So this would be 7 out of 12. I think I can just pull up the calculator here on the page. Yes, 7 out of 12. And then we're going to multiply that by the second one. We ate a milk chocolate. It's gone. That's going to cut us down to 6 milk chocolates left. And it's no longer out of 12. It's going to be out of 11. So this is over here. It's all decimals. This says answer as reduced fraction. I'm going to hit this functions button and this FRAC right here that my mouse is on. This will convert it back to a fraction. It pops up. 7 out of 22. So that's what I type in here is 7 out of 22. And it says, good job, you got it right. Okay, so hopefully that gives you a bit of guidance. You should be all right working your way through this. Okay, good luck with this. If you have questions on it, again, wait till I come back and everything should be good. You can ask me when I get back to class. This is scheduled for tomorrow and due on Friday, and I'll see you in class then.